Good afternoon, dear students. Today, we continue with application of side-chain polymer liquid crystals as optical information storage media. After semester break, we'll have one more subtopic, which is the application of side-chain polymer liquid crystals in nonlinear optical materials. Side-chain polymer liquid crystals have tremendous potentials as high-value polymers. This is because it is a hybrid system between the electro-optical properties that shown by low molar mass liquid crystals and the physical properties of conventional plastics. This combination produces an interesting products that can be exploited for new technologies such as in optoelectronics. Optoelectronics is a field of technology that combines the physics of light with electricity, based on organic materials, particularly as media for optical information storage and optical information processing. A thin film of a side-chain polymer liquid crystals appears opaque in the liquid crystal phase due to random orientations of the director which scattered light. Applying an electric field to the film causes the directors to align and the film then appears clear. In conventional liquid crystals, switching off the field reverses the situation, but in side-chain polymer liquid crystals, the film stays clear because the directors remain aligned. The only way to randomize the directors is to heat the material in the absence of an electric field until it melts into a normal liquid. This behavior can be exploited to record information using a laser that can heat tiny spots in the film, giving rise to the use of side-chain polymer liquid crystals as laser-addressed optical information storage media. In optical information storage, typically, a side-chain polymer liquid crystals is sandwiched between two glass slides coated with a transparent conducting layer, analogous to that used to display information in low molar mass liquid crystals devices, as shown below. Liquid crystal polymers are ideal for erasable compact discs, CD. The process in writing and erasing the data are illustrated on the diagram. A. An electric field aligns the domains to give a clear film. At this condition, there is no information written in the CD. B. To write any information in the CD, a laser then melts the film. The domains lose their alignment to give opaque spots which store the information. C. To erase the information, laser with the electric field can be used to align the director and the film then appears clear. D. The disc is then ready to record again. A homeotropic alignment of the director is produced across the device by using a large electric field. The blank medium thus appears optically clear, or dark viewed between crossed polarizers. Irradiations of the device by a focused laser beam results in localized heating of the polymer, raising its temperature to above the clearing temperature. This effect can be enhanced by incorporating a dye, which absorbs at the wavelength of the laser, usually in the infrared, chemically bonded to the polymer backbone. As the addressed spot cools, the liquid crystal's phase forms with a random director distribution. The spot appears opaque against a clear background. The contrast of the device can be further improved if it is viewed between crossed polarizers, in which case the written data will appear white against a dark background. Selective erasure of information can be achieved by addressing a written area with the laser, and allowing the locally heated regions to cool in the presence of a large aligning electric field to achieve the original homeotropic alignment of the director. This leads to e-draw, erasable direct read after write, re-recordable compact discs for hi-fi market. Side-chain polymer liquid crystals exhibited several advantages over magnetic and magneto-optic materials. Side-chain polymer liquid crystals are better long-term stability of the stored information, which can sustain up to 10 cubed to 10 to the power of 4th erasure write cycles without material degradation, as well higher contrast between addressed and unaddressed area. The disadvantage of this e-draw, erasable direct read after write, is need to incorporate appropriate laser power sources and high voltages in the recording equipment, together with the optical control systems required for accurate selective erasure, meant that optical discs based on the new materials could not be made compatible with existing CD technology at competitive prices. As a solution, they have removed the need for electric fields and designed a system which relied on the contrast between the naturally highly scattering, opaque, texture of the macroscopically disordered side-chain liquid crystalline polymer film, and the clear or transparency appearance of its isotropic phase. Glass transition temperature, Tg, is below, but close to, the clearing temperature. A laser heats spots, or lines, in the opaque film so that they melt to become a clear isotropic liquid. When the laser beam is switched off, the heated area is allowed to cool rapidly. Because of the proximity of the clearing temperature to glass transition temperature, there is no time for the molecules to arrange themselves into the aligned opaque liquid crystalline phase. Instead, the molecules in the affected area become trapped in its isotropic phase as a clear glass. To erase information, the written area is addressed by the laser, and allowed to cool sufficiently slowly for the liquid crystalline phase to form prior to the onset of the glass transition. However, selective erasure of information is not easy since it is difficult to achieve sufficient control over the cooling rate. This type of device is ideally suited for the archival storage of information, as were, write once read many times, media. Because the device does not require electrodes, the liquid crystal polymer film can be directly laminated onto carrier substrates, example polyesters. This allows the format of the information storage medium to be adapted to particular applications. A further and important advantage of using side-chain polymer liquid crystals as worm media is that they do not require wet processing to fix the information, thereby affording a significant reduction in production costs.